Hello, friends. So, we will see quickly about the helical path of a charged particle in a magnetic field. Now, if let's say this is the magnetic field and a charged particle enters in this magnetic field making some angle. So, this is the charged particle and it enters in this magnetic field making some angle theta. Now, we will resolve this speed into two components. One, v sine theta. This is the component of speed which is perpendicular to the magnetic field direction, and another component will be v cos theta. V cos theta is the parallel component of the uh, velocity along the direction of magnetic field. Now, due to this v sine theta, charged particle is moving in a circular path, whereas due to v cos theta, charged particle is moving in the linear path. So combining these two paths, it will follow this type of path which is called helical path. Normally in exam, you will be asked to find out the pitch and time period of its revolution. So first, we will see what is the time period. So time period of revolution of this charged particle will be given by 2 pi into radius of the circular path divided by velocity component due to which it is moving in circular path, that is v sine theta. Now, how to find r? R is given by, you know that r is equal to mv by qb. Again, here v will be that component due to which it is moving in the circular path. So if you use this one, here, you will get 2 pi m. V sin theta will cancel out and it will become qb. So this is important to note that time period will be given by 2 pi m by qb, which is independent of both speed and its direction with the magnetic field. So this time period is always constant. And this property is used in one device called cyclotron. Okay. Now this is the time period. It is that time during which the particle is completing one rotation. But by the time it completes one rotation, it will move in linear path also. So we will find out what is the distance moved by the charged particle along the direction of magnetic field in one time period, and that distance is called pitch. So if we look into this, so pitch is defined as it is the linear distance or horizontal distance moved by the charged particle during one rotation. So we will write pitch is equal to time period into the component due to which it is moving in the linear path, that is v cos theta. Now we know that time period is given by 2 pi m by qb. So we will just multiply this v cos theta. Now see here, pitch is directly proportional to speed. It is directly proportional to cos theta, right? So if the charged particle is moving with a great speed, then its pitch will be more. Similarly, if it enters the magnetic field at a smaller angle, then also its pitch will be more. So let's say if the question says that there is one charged particle which is moving in let's say at 30 degree, and that same charged particle is again entering at an angle of 25 degree, then which one will have more pitch? So obviously if the speed is same, then this 25-degree angle, this particular scenario will have more pitch. That means it will move like this, whereas this one will make smaller pitch. So this type of question you can face. So you have to remember the formula for pitch and time period of revolution, right? So this is what you should know. about the helical path of a charged particle when it enters the magnetic field in a direction which is not 90-degree, which is not 0-degree, which is not 180-degree. Okay, so please note it. Thank you very much.